Good afternoon, college algebra friends. I'm going to be walking you through 7.5, or solving exponential and logarithmic equations, and just trying to walk you through some of these steps. Don't get overwhelmed the way they look. It looks a little intimidating, but they're actually not all that bad. You just need to kind of bear with me and hang in there, and I'll do what I can to make it as easy as possible. So one of the things that you need to kind of recognize at first is if a logarithm or an equation is written either as a logarithm or is it written as an exponent. Well, when I'm looking at 1 through 4, all of those equations are written in what we call exponential form. In other words, the x is in the exponent. So you kind of do the opposite of what it's presented as. So if you have an exponential equation, remember the opposite of an exponent is a logarithm. So I'm going to take the logarithm of both sides of my equation in order to eventually solve for my x. Okay, so I'm just going to kind of walk you through these first 4, and because I'm kind of limited on some room, I'm going to do number 1, and then I'm going to erase it and then do number 2. That way I've got plenty of room in my little section here. Okay, so number 1 says 10 to the x plus 7 power equals 29. Well, because the exponent has the variable x, and I'm always solving for x when I want to, solve an equation, to get that exponent down, I just take the log of both sides. Now, since it's a value, a number, I'm going to take a common log. So I'm going to use common log. So basically, I'm understanding that I'm going to log both sides here. So in other words, I'm doing log of 10 to the x plus 7 equals log of 29. Well, when I log this left-hand side, remember down in front, that rule for exponents, when you take the log of something and it has an exponent, that x plus 7 is down in front. So he's going to come down in front. So x plus 7. And then I've got the log of 10 equals log of 29. Now, guys, the log of 10 is a number. And so when I see the log of 10 being a number, it's basically, I can do it in my calculator if need be. But remember, if a log base is not shown, it's understood base 10. So log base 10 of 10. Well, it's asking the question, 10 to what power gives me back 10? Well, that's a 1. Okay, and so log base 10 of 10 is 1. And so really, I just have, let me change back to my correct pen here. Sorry about that. I'd basically have just x plus 7 on the left equals, and then log of 29, I can go ahead and find what that value is, or I can leave it as is right now, because I'm just going to eventually solve for x, and so you're going to subtract 7. So you're really going to do x is equal to log of 29, take away 7. Just enter that into your calculator as is, and you get x equals negative 5.54. And that's all there is to it. Okay. Okay, looking at number 2, I have to do a little tweaking first. The 3 in front of the E needs to be eliminated, because I can't take the log with a number in front. with that, that 3 being in the way. So if I divide both sides by 3, I'm going to have e to the negative x plus 9 power equals, and then 142 over 3. Now, you're going to say, well, I need to make that a decimal. Well, Hawks is not going to let us make that a decimal. Okay, so I'm just going to have to let that stay as 142 over 3 for the meantime. All right, now, to eliminate the e, remember e is not a common log, it's a natural log. Well, to do the opposite of it, I take natural log of both sides. So this just disappears, and that exponent, negative x plus 9, just drops. Equals, and then I'm going to have the natural log of, and I'm going to leave that fraction, 142 over 3. Now, when I get to this point, I'm going to subtract 9. And I'm left with negative x equals, and then it says when I subtract 9, ln 142 over 3 minus 9. But you see I've got a negative sign in front of the x. So what I'm going to have to do is divide all the way through by a negative. So if I divide by a negative, here, dividing by a negative 1 here, dividing by a negative 1 there, gives me negative natural log 142 over 3 plus 9. Okay, now, the reason I have to keep the fraction in there at first, because it says write the answers both as an exact expression. So that's what I have there. This is called an exact expression. Okay, that's showing the logarithm not as a decimal. But then they also want me to make that into a decimal, so round it to 2 places. So all I'm going to do is place this into my calculator just like I see it. And so the second part of that answer is x equals 5.14. So I'm going to have 2 answers, two things that I'm going to use. All right, so backing up to the first one, number 1, remember when I got to this step here, x equals, and log of 29 minus 7, before I put that into my calculator, that is the exact expression. And then when I put it into the calculator, remember me getting negative 5.54, that is the decimal expression. Okay, and so they wanted in that notation both of those. All right, so looking at the third one, I already have e without a coefficient in front of it, so there's no need to divide. I can't. So I'm actually going to take the natural log of both sides. And in doing that, this cancels, and the 2x minus 5 just drops. And then when I take the natural log of the right-hand side, 74 to the 5x plus 1 power, remember the exponent comes down in front. So 5x plus 1. And then I've got the natural log of 74. Now, this one's a little bit more involved in the sense that on the right-hand side, I'm actually taking the natural log of 74 and I need to distribute it across the 5x plus 1. So the left-hand side stays. So I'm just going to kind of spread it out a little bit. 2x minus 5 equals. And then I have actually two terms when I expand this. I have 5x times the natural log of 74 plus, and then there's a 1 here. So, I mean, I can put the 1 for the moment, but Hawks probably won't be kind to me and allow me to keep it there. But 1 times the natural log of 74 is just the natural log of 74. So if this were a 3, here in this spot, then I'd have to say 3 times the natural log of 74. But since it's just a 1, I don't have to do anything with it. Now, again, I am trying to solve for x. Well, the issue is this term here has an x. I need to get x's together. So I'm going to take 2x and pair it with the 5x times the natural log of 74. So this is actually going to go over here. So it's minus 5x. And then you can say natural log of 74. I kind of did it in a parenthesis. I kept the 74 in a parenthesis. Now, both of those terms contain an x. So down the road, you probably think, okay, I'm going to have to factor out an x. Now this 5, this negative 5 on the left-hand side, I'm actually going to take it over here. So what's left on the right-hand side? Well, natural log. And now I'm going to embed the parenthesis around the 74. Plus 5. So I took, in other words, this term here over to the right, and I took this term here, over to the left, and then this term here over to the right. And then I'm just going to continue on. Both of the terms on the left have an x, so I'm going to factor out an x. And I'm going to get 2 minus 5 natural log 74 equals, and I'm going to keep this, I'm not going to write this as a decimal or anything, natural log 74 plus 5. And so at this stage, I'm going to eliminate the information next to x. So I'm going to divide by 2 minus 5 natural log 74. What do you do to one side? I go to the other. 2 minus 5 natural log 74. That way this all cancels. And what you see here, that's on the right-hand side, is the exact expression. So that's what's equal to x. So that will be your first box for the exact expression. And then you're going to type in exactly the way you see this exact expression into your calculator, and you're going to get a decimal rounded to 2 places. So I got negative 0.48 as your decimal. A little overwhelming, but again, after you do 2 or 3 of them, they're very similar. So get your x's on the left, get everything else on the right, factor out an x, and then divide by what you don't need. Okay, question 4. Similar to question 3, there's no coefficient in front of e, so I'm just going to take natural log. drop your exponents. So I'm going to slide it over here. That way I have some room. 3x minus 10 equals the 3x over 8 comes down in front. And you're working with the natural log. And I'm going to put a 5 inside of that parenthesis. Now, fractions. Oh my gosh, what do we do? Well, I'd love to get rid of that 8. So if I get rid of this 8, I can multiply everybody through by 8. And if I do so, I'm going to distribute it across to the left-hand side. And I really end up getting 24x minus 80 equals 3x times the natural log of 5. Because on the right-hand side, that just cancels. Because this is all one term. So 3x times the natural log of 5. And when I get to here, I'm just going to get x on one side. So this is actually just a skosh easier. This is saying I'm going to take this entire term here over to the left, and I'm going to take this entire term here to the right, because I want to pair up everybody with an x on the left. So it's going to look like this, 24x minus 3x natural log of 5 equals, and then when I take negative 80 over to the right, it's going to be positive 80. Looking on the left-hand side, I need to factor out an x. So I'm left with x, parenthesis, and it's going to say 24 minus 3 natural log of 5 equals 80. And then divide by what you don't need. So I'm going to eliminate 24 minus 3 times the natural log of 5. And I'm going to divide it over here by the same thing. So, canceling, exact expression, 80 over 24 minus 3 times the natural log of 5. And then put this into your calculator exactly the way you see it, and you will get a decimal of 4.17. So 2 answers you're looking for. So hopefully that's not too overwhelming for you. Okay? All right, moving on to the next question. I actually put some information on the next screen because I'm going to run out of room here. So this is back to what we kind of sort of did a few lessons ago. I think it would be 7.2 when we're investing money. And so just revisiting the formula we had before. And so investment, we're going to talk about gaining a new amount, and we're going to take our principal, and this is the formula we're going to kind of use. So we're going to go 1 plus the rate as a percent over n, and n stood for the number of times you're compounding your account. And then where n is located, it's both in the the denominator, and then as an exponent. And so some of us were struggling a little bit about what does n stand for in a particular problem. Well, I kind of made you a few notes. So if you're compounding annually, your n will be 1. Semi-annually, you'll be 2. Quarterly, you'll be 4. Monthly, you'll be 12. And daily, you'll be 365. And so we're just revisiting this formula, and you're thinking, well, why are we doing this again? Well, it's what we're solving for. So putting in the information, so hopefully you can look at the question while I'm writing down the numbers of where it belongs. It says, Alfred's saving some money to put a down payment on a car. He currently has $4,646. So that's his principal. So $4,646. He's starting out with that much. But he knows he can get a loan at a lower interest rate if he can put down $5,626. So that's what he wants to end up with in the end. 5,626. And so filling in the rest of the info, 1 plus, well, the rate that they're going to use earns 4.2% interest. So remember to put that as a decimal. It is being compounded quarterly. Okay, so there's going to be a 4 here underneath the 0.042. And not only do I put a 4 in the denominator, I put a 4 as part of my exponent. And then it says he does this, for so long. How long is it going to take him to accumulate that money? So I am looking for the t. I don't know t. So there is the unknown. It's the exponent. So keeping in line with what we've been doing on the last few problems, we're going to have to use a logarithm eventually. So let me walk you through your steps. It, again, looks intimidating, but it's really, you're going to do just a few things. Step 1 is let's get rid of this principal. So let's divide both sides by 4646. And I end up getting, on the left, 1.2109. And then on the right, I'm going to go ahead and put 1 plus, and then I'm going to go ahead and figure out the decimal of that. So 0.0105 to the 4t power. Now, at this stage, I want to move that 4t down. He needs to come down in front if I can. So if I log both sides, now guys, I can log or natural log, either one. I like doing common log. So if I common log both sides, then this is just the log of 1.2109 equals, and remember this comes down in front, 4t times the log of, now, what is that number right there? Well, when I combine that, that is actually 1 plus 0.0105. It's really 1.0105. It's what I'm taking the log of. Oops, put my parenthesis around the wrong thing. So there we go. Now, when I get to this step, I want to again solve for t. Well, there's two things I'm going to have to kind of sort of be doing. I'm going to eliminate the log 1.0105 on the right. So let's just divide by that. What I do to one side, I got to do the other. So gone. And I get 4t equals, and this comes up to be on the left-hand side, 18.321. I'm not quite finished. I want to find t. So I'm going to divide by 4. So t is equal to, and it says round to 2 places, 4.58, and time is in years. So it's going to take him a little over 4.5 years in order for him to gain the amount of money to be 5,626. Okay. So a little different spin on a question you've seen before. All right. Moving on to the next questions. Now we're solving a log equation. A log equation has the words logs in it. So what you need to do is the opposite. How about create exponents out of them? So that's exactly what we're going to do here. So if I create an exponent out of this, I need to do a little bit of rewriting. So looking at number 1, 2 times the natural log of the quantity x minus 3 equals the natural log of 7x. Well, the 2 right here, this little 2 at this point in the game, he came from somewhere. So let's think about where he came from. Well, he came from up above. And so a couple of lessons ago, we talked about if you have the natural log, same base, of the left-hand side equal to the natural log of the same base equal to the right-hand side, these just cancel. These are gone. They disappear. So I really have x minus 3 quantity squared equals 7x. And now I just have a quadratic. So let's FOIL this out. So it's x squared minus, and then if I front times back, doubled, minus 6x plus 9 equals 7x. I need to solve it, so subtract 7x from both sides. So x squared minus 13x plus 9. I'm going to get to this point and say, okay, what's x? Well, sadly, this little guy's not going to factor. So I'm going to have to revert back to something that I've used many, many times before to figure out what x is. And it's our old friend, the quadratic formula. So I'm ended up going to take opposite b. So I'm looking at 13 plus or minus. So I'm going to end up doing b squared minus 4ac all over 2a. So at this point in the game, it says round it to 4 decimal places. You do not have to do an exact expression on these. They just want 4 decimal places. So looking at what this will give me in my calculator, just kind of saving a little bit of time, I'm going to end up with 12.2663. And I'm also going to end up with a negative number. So my negative number I'm going to end up with, after I calculate it. Okay, I went back to my calculator and I found the other answer, because remember, quadratic formula, I want to get 2 sets of answers. It didn't happen to be negative. It was scratched out in my notes, but the reason I scratched it out is when I go back and check 0.7337, I know 12.2663 is okay, but when I do this and I come back up here and I plug that answer right there for x, because that's what I'm doing, plugging it back into the original problem. If I type that in my calculator, 2 times the natural log of 0.7337 minus 3, this gives me a negative answer when I get that. 2 times the natural log of something negative. I'm not allowed to take the natural log or common log of anything negative. So what happens is this gets thrown out. I don't get to use it. So the only answer I get to use is 12.2663. Okay, so I'm going to stop here because I'm at almost 30 minutes with this lesson, and my video may be too big to upload or take forever. So I'm going to stop, and I'm going to do part 2 in another video and finish the rest of the page.